In this video, I'm going to show you how to segment remote sensing imagery using the SamGeo 3 powered by Meta's SAM-3 model. So SAM-3 stands for Segment Anything Model 3, and it was released by Meta about 2 weeks ago. It's a very powerful foundation model that can segment images, videos, and I have spent a couple of days integrating that into the SamGeo Python package. So now you can use that to do remote sensing image segmentation easily without having to train your own model. And here is the website. The link is also in the video description below. If you want to learn more about the SAM-3 model, you're welcome to check out the website. Essentially, here you can compare SAM-3 with SAM-1 and 2. So SAM-1 basically only is a foundation model for segmenting imagery. So SAM-2, they add the video capability that you can track objects across different things. SAM-3 is even better. It adds text prompt functionality and also allows you to select example from the object, from the imagery, and then you can detect all the similar objects. And it's very powerful. We can adapt that to do geospatial or other medical imagery. There are a lot of downstream applications. So for this video, I'm just going to show you how to get started. It's going to be very easy. You can go to the SamGeo website. The link is in the video description below. On the left side here, click examples, and then go to SAM-3 image segmentation. If you have GPU, you can run this one on your local computer. If you don't, you can run it using Google Colab. So just right click, open this one in Google Colab, and make sure that you switch to the GPU. So click the runtime, then click change the runtime type. From here, change to T4 GPU. Otherwise, it's going to be pretty slow. And the other thing that you need to do is to make sure that you request access to the model. It's hosted on Hugging Face, but you need an account and also need to request access. So what you can do here is just click the link and it will take you to the website. From there, there's a link that you can request access. So right now, here you need to log into your account. So log into your Hugging Face account, and then I believe somewhere there you need to submit a form to request access. Otherwise, you won't be able to use it because it's not fully open source model. They want to get some user information so that you can use it, but it's free. So once you get access, then you can run this novel. Otherwise, you will just get familiar with the process. You can wait later once you get access. I think it only takes a couple hours after the review and grant you access. So I'm going to show you how to do that. And so here I've already have this one on my local computer. I'm going to show you just using, you can open it in VS Code. You need to install the package. So all you need to do is just pip install segment-geospatial and then square brackets SAM-3. It's going to install all the required dependencies needed for SAM-3. So by default, it's not included in the SamGeo core package. So make sure that you install this one. And once you have that, you can run through the steps. So I'm going to show you step by step how to do that. It's very simple. We are just going to use SAM-3 and also the leaf map for doing interactive mapping. Just import the libraries and then select the kernel. And it should take a couple seconds to load all the packages. It's going to show you here to install, to use SamGeo 2 as install this. We don't need to because we are using SAM-3, so we have already installed everything. After that, you can use the sample data that I provide here, or you can use your own data. So for this one, I'm just going to use the imagery from Hugging Face. So it's going to download the imagery, just click, and then it's going to download imagery. After that, you can see the imagery, just create an interactive map, and then use the add raster function to add the raster to the imagery. And you can see here, this is an imagery covering UC Berkeley. So it's a campus imagery. You can see some big buildings, also trees, grass, roads, something like that. So what we're going to do is to use this image to segment object from this remote sensing imagery. And you're welcome to replace this imagery image path with your local data, whatever data that you want to use. So it can be satellite imagery, air imagery, drone imagery. Just replace this one with your local file path, whether if you have the file path on a computer, just replace, so you don't necessarily have to use my imagery. And then once you have this, then you need to uncomment this. And this is one time only if you are running it on your local computer. If it is on Google Colab, then you need to do this one every time. So let me quickly go back here. Anyway, so let me switch to the, I don't need the GPU, so the CPU is faster. And so I can just uncomment this one and then just run anyway. It's going to pop up, ask you to install the token. So make sure that you log into your Hugging Face account and then create a token. You can follow the instruction here if you don't know how to generate a token. So log into your account, then you should be able to get your token and then just paste your token here, log in, and then it's done. But if you're using Google Colab, you need to do that every time. For local, I don't need to. So I've already authenticated before. I don't need to run this one. And next, we can start creating the SAM-3 model. All we need to do is just to pass into this SamGeo3 constructor, and you can specify which backend you're going to use. So the backend by default is the Meta, but Hugging Face also has the SAM-3 implementation. Ideally, the tools should be the same, give you the same result, but from my testing, it doesn't. I'll show in the next video what's the differences. So this is why I added the backend Meta and also transformer. So again, there's two different versions. And I noticed that for the transformer, it actually gives you better results when you're trying to segment some other objects. But in this example, we're just going to use the Meta backend here. And then for the device, if you have GPU, basically this one you don't need to specify. If you have GPU, it's going to use a GPU. If otherwise, you're going to use a CPU. But sometimes, if you have a large imagery and then your GPU is not enough, you're going to throw errors. In that case, you can specify the device as CPU. So in that way, you can run it slower, but it will be successful because your imagery is too big. And you can also specify the checkpoint path. The checkpoint path basically is if you already have the SamGeo3 downloaded somewhere, and you can actually put it on other computer, then you don't have to re-download it every time. So you can just point into this file path, and then if you specify the checkpoint path, you want to check this one low from Hugging Face to false, because you are using your local checkpoint path. Basically, if you have already downloaded the checkpoint, you can specify that, especially if you're on a computer that doesn't have internet access, for example, then you might already have the checkpoint, the .pt file on that computer. Then you specify this one and change this one to false. You should be able to do that. So let me show you here. We are going to just create a model, and I can here show you the GPU, for example, the GPU usage. By default, it should be just like close to 0. And after the it looks like I maybe accidentally clear the cache. I actually already downloaded this one before, so it might take a couple minutes, depending on your internet speed, to download the model. So the model itself is 3.45 gigabytes. So you need to make sure that you need to have at least a GPU with at least 8 gigabytes, because besides loading the entire model into the GPU, you also need some memory, the VRAM for processing the imagery. So the intermediate, save the intermediate result, because when it's running, it's also going to load the imagery. So it depends on how big is your imagery and how complicated, how many objects within the imagery. If you have too many objects, then so for basically for each object, it's going to take the same amount of space for that imagery, the width and the height, because it's the same. Each object basically is going to have the same size, and it's going to chip a big. So if you're trying to process a large imagery, it's going to take a lot of GPU. But at least I think you need at least have 8 gigabyte of VRAM. For me here, I have my computer has 2 GPU, each one 16 gigabytes. So the NVIDIA RTX 2000 ARA generation, 16 gigabyte here. Right now is using 1.269 gigabyte. And the other one is the RTX 5060 Ti, also has 16 gigabytes. So it's sufficient for running my demo here. But if you try to process a much larger imagery, then you might want to consider subdivide the imagery into smaller sections, and then you do the segmentation, then you can merge them together. So just wanted to let you know. And this one I think is bigger than the previous generation. So same one I think is about 2 GB, and SAM-2 actually is they have different versions, large, small, huge. So some of them are only a couple hundred megabytes, so it's become smaller. But now SAM-3, because they added a lot more functionality, so it becomes much larger. Oh, by the way, so for SAM-3 here, you can also specify the BP path. So basically the vocabulary Meta provide that one in their GitHub repository. But if you have others, you can specify your own vocabulary if needed. So we're just going to use the default one, and you can see now we have finished downloading the model, the checkpoint basically from Hugging Face. As you can see, now it's actually occupying my GPU. So earlier was like less than 1 GB, now it's 4.34 GB. You can see the line here. So that means right now the model has been loaded to the GPU, is a good sign. Once you have that, also by the way, make sure you see this one using the CUDA device, because I have the CUDA installed on my Linux computer. Once you have the model, now we can set the imagery. So basically the model has been loaded to the GPU, and the imagery basically just set imagery and then provide the imagery path, and just run this one, and it should increase the GPU a little bit more, but not too much. So you can see 4.84, right? It's about 500 megabytes. So it's been loaded to the GPU. Now we can start doing the segmentation. So it's very simple. All we need to do, just specify the text prompt. So depending on what you want to detect, like I want to detect the building, then just run this one, generate mask. And it's super fast. Take a look. Take less than 1 second. The imagery is decent. It's not too big, but it's like seconds. Within a second, you get all the imagery. And it's going to tell you, okay, we found 46 objects. And after that, you can just say show annotation. And this one is going to take a couple of seconds because it's using matplotlib to load all the imagery. If your image is too big, you probably don't want to use this one, but just for demo, if you want a nice visualization of all the objects overlay on top of the imagery, and also have the bounding boxes and also the probability, then this might be the way for you to actually visualize them easily. And as you can see, we have 46 objects, and it has been detected automatically. All we did is just provide a text prompt, and that's it. And this is super nice. It's so much better than SAM-2. SAM-2 basically is has the text. SamGeo too has the text prompt functionality, but it's based on grounding Dino, and the result is not as good as this one right now. So we have native support for text prompt, so it's so much better. If you want, you can click this here to save this one to your computer if needed. So by default, it's going to show you just basically the imagery over there, but you can also call this show mask function. It's going to show you just the mask without the setup imagery, without the bounding boxes, and you can also change the color. So here also I specify the unique equal to true. That means for each object, it's like instant segmentation. Each object is going to have like ID, a unique ID. But if you don't really care about the uniqueness, you just want the binary classification, then you want to change this one unique to false. Unique to false. Then it should just show you just one color. Also, you can change the color map. So for example, CMap equal to gray, for example. But if it is gray, then you're just going to be a binary imagery, yes or no, right? So now you can see we have the binary imagery just showing you all the buildings. Of course, there are some like artifacts in here, some like in the center is not perfect. We might need to do some cleanup, but overall, it only takes 1 second for us to quickly get a preliminary results without having to change our model. So it's super powerful. And if, like I said, you can click here to save this one to a computer if needed. So this is one way using the text prompt, but you can also use the bounding boxes. So if you already know, for example, this is the sample object I want to detect. I give you this sample, and then you help me find all the similar objects from the imagery. In this case, you can define a bounding box. So the bounding box of this surrounding object, right? And all we need to specify a list of bounding boxes. And so this will be in the lower left corner and the upper right corner. So x min, y min, x max, y max. So you might be wondering, like, how do you get this one easy? You can go back to the, let me show you here. If you want to try other bounding boxes, it's actually very easy to do, right? So this is the map that we have. And all you need to do is just go to any object you want to detect and then draw a bounding box. So for example, I can draw somewhere. Let's say I want, this is the building I want to give you as an example, and you have me detect all the buildings. So in order to do that, you need to get the bounding boxes. So after I draw the bounding boxes, bounding box name just m.user ROI underscore bounds, and then just click. It's going to show you the bounding boxes. Then you can copy and paste this one to your program. So all I need is just Control C here, and then I can come back to this example here. Make sure that you have this list of lists. Okay, so remove it, Control paste. Now I have this one inside here. So this is the list of bounding boxes, and then the box labels. So depends on how many points you have. The box labels, if there's just all of them are true, that means it's going to detect all the objects. But you can also have negative labels. For example, if you have multiple objects and there's some object you don't want to, I can have another list here, and then for here I can say comma first. Of course, this is the same bounding boxes, but just as an example, what I'm saying is if you have other object that you don't want, then you paste that bounding box here, and then have the box labels equal to false. In that way, it will exclude the object. So in that way, you don't have to remove the false positive. So if this is something you want, you can do that. I'm going to reverse back to just 1 point. So I have one bounding box, I have one label to true. That means, okay, that's the object I want to detect. And then we just call this generate mask by boxes. And inside here, we're going to pass in this box. So the box is the list of bounding boxes, and then the box label. So this one is optional. If you all the objects is true, like the object you want to include, you don't necessarily have to include this one, but you do need to provide this one. So the bounding box coordinates. In this case, we are doing geospatial imagery segmentation. So the bounding boxes, these are all latitude and longitude. So you need to specify the EPSG 4326. Otherwise, it's going to use the row and column number. So basically, you're going to use the location of the bounding box within the imagery, and that might not be what you want. If your imagery is GeoTIFF, then you normally want to set this one. But if it's just a JPEG, I'm going to show you in the next tutorial that if it's a JPEG, then you don't need to specify the coordinates because you're just going to use the row and column number. So let's just run this one. And take a look, now we have 43 objects, so it's a little bit smaller than the text prompt segmentation, but it's close. So there might be some small minor small object that were detected. And so it has finished the segmentation. If you want to see the bounding box, of course earlier I drew the bounding box on the map so you can see that, but if you want to show the bounding box on the imagery, it will show here, show bounding boxes, and then the box, the label, and also the B-box color here. And as you can see, we have this one. So this is basically what we use as an example to tell the model that I want you to find all the objects similar to this one, and it's going to find all the buildings. After that, we can show the result. So similarly, we can just call this show annotation. It's going to basically have a unique color for each object, similar to what we did earlier using the text prompt, but now we're using a bounding box. So it's pretty much similar. Although there are three objects like different, but it's really hard to see. But it's just the smaller one. You might need to compare the result later if you want to. But we get the similar result. So right now, if you look at this one here, the probability is 0.93, and this one is pretty high. The reason for that because we use this one as an example. If you go back to the previous example, I believe it's probably a much smaller number. So let me go back to this one. Oh, 0.95, even higher. Interesting. Anyway, so these are the ways that you can use to segment the imagery. So you can either use text prompt or you can use bounding box. And once you finish the segmentation, you might want to save the result. So you can just call this function save mask and then provide the output. And here, whether you want to have a unique ID for each one or not, So if unique equal to true, that means you're going to basically do instant segmentation 1, 2, 3, 4, 5. If you just want a binary imagery, then you just be binary. So then the unique you can set to false. So this has been all been saved to the computer. Also, you can save the confidence score, because SAM-3 also return the basically the probability, the confidence score ranging from 0 to 1. So the higher the better. And sometimes if you want to evaluate the confidence scores, you can also save this one. So in addition to the output, okay, building mask with scores. So basically just the building mask, and then save scores. If you can specify here, click here, it's going to show you save score. So this is the one that if you want to save another imagery. So this one is the floating point value ranging from 0 to 1, and then unique equal to true. That means we're going to save 2 images, the mask and also the score. And for the show mask, you can I think this is just showing you the similar to what we did earlier, just showing you the unique ID, so how many objects in here. And so lastly, let's put all the data all together on a single map so that you can compare the differences. And we're going to load the building mask. We're also going to load the building score together. Now visualize this one. So let's look at this. This is the bounding box. We can remove it since we're it's no longer needed. And upper right corner here, you can use the slider bar here to turn the layer on and off, right? So we have the building score, we have the building mask. So the building mask is basically just instant segmentation. So each object has one unique ID. And the building score, this one using cool warm. So basically the light blue color is low probability. That red color, that means high probability. So you can see here, this one is really high because it's the object we use to do segmentation. So it's kind of a normal. And also have the building here. All right, so just a couple seconds, we do the segmentation for all the objects within this region, and then we get all the objects pretty much easily. And there's some like artifacts in here. For example, this is, you can have some like small tiny object in here. If that's the case, when you do the segmentation, you can set a minimum size. Right now, this is probably, I think, maybe 15 pixels, something like that. So if this is like way too small for the object that you want to detect, you can go back to here. When you generate the mask, you can, let me see here, save mask. Let me go back to the bounding box. Okay, and when the about step, so you can specify the minimum and the maximum. So if you hover your mouse over this generate mask by boxes, it has 2 parameters, the minimum size and the maximum size. So by default, because we're using minimum 0, so basically all the objects going to be detected. If that's not the case, I can just set, for example, minimum size equal to maybe 1000 pixels. It depends on the imagery and also the common size. So you need to check the spatial resolution of the imagery and then multiply by the number of pixels. Then you get the area. So, and for example, this might be less than, let's say, 20 square meters. You don't want it, and that's good. So we can run this one again, or still 43. Maybe we need another one. 10,000. Okay, now if I change to 10,000 pixels, we only have 34 objects. So this is how you can actually filter the objects. So let me run this one again, save the mask, and then save the mask. Then we can load the imagery. When we step, now you should see a smaller number. Some of the smaller objects should be gone. Let me turn this one on here. Oh, interesting. I think these are being treated as a single object because the same color. But there should be some buildings not being detected because we only detected 34 objects. So you can compare the results if needed. And this is how you can segment remote sensing imagery using the SamGeo 3. Just with couple lines code, it's so much easier to use. I had spent a lot of time trying to simplify the process, so now you don't have to compare to the original SAM-3 let me show you here. If I go to the SAM-3, they have the Hugging Face, the GitHub. Where is the GitHub? So go to here, Facebook, and then SAM-3. Okay, so it's here. If you're interested in learning more about the original like implementation, you're welcome to check it out. But I make it much easier. So this is original example using the SAM-3 image predictor, and this is how they used to do the segmentation. You see, it's quite a lot of code, and it doesn't really apply to geospatial data. So I simplify the process, and then it's even easier than just using the package here to do the segmentation. And that's all. But the next video, I'm going to show you how to do segmentation on non-geospatial data, and also how to do interactive segmentation without having to write codes. You can just draw bounding boxes, or you can enter a text prompt on the map to do segmentation. Okay, that's all for this video. I will see you in the next one. Take care. Bye-bye.